didn't get it during the exam, but uh, I feel like I've solved it.
Okay,
Uh,
let me also see if we can do it.
yes, sir. So this is ISI 2023 UGB question 1.
Okay. Okay.
So now determine all integers n greater than 1
Hmm.
such that every power of n, and they mean every natural power, so
Hmm. Such that every power of n.
has an odd number of digits.
Okay.
And it is assumed that they're talking about base 10.
Okay.
So, sir, if you like, what I did was I experimented a bit. 100 works, 1000 works. Sorry, 1000 doesn't work. 10 to the power 4 works, and all these parts of 10, all these even parts of 10 work, but any other number doesn't work. So I was trying to see how to prove that. And what actually happened was someone on MathStack Exchange asked this, and someone answered it. Uh, but like before reading the answer itself, they gave an idea. So I thought of using that idea and proving for myself. So what they gave was the number of digits in n is
Uh,
given by floor of
Number of digits in n. Yeah.
floor of
Log n
log
based.
base 10.
Right. That's
Yes,
what it has to be, right?
yes, sir. Plus one. Like they gave this, but it's actually plus one.
Yeah, that's give
He,
or take. Yeah. I don't. Yeah.
yes. So now using this,
Yes.
uh, we have two cases, sir. Suppose n is equal to 10 power. Suppose this log base 10 of n is an integer, right? So suppose n is a power of 10.
Yes, in that case you have to do. And other case it will sort of be a continuous function, so it will take all values, right? Means in the sense that it will take odd values, it will take even values also, right?
Yes, yes,
Something like
yes.
that, right? Yeah.
That's
Uh,
how I proved it. Yes,
Yeah,
sir.
but anyways, that's tell me what is.
So sir, if n is equal to 10 power
No, wait. So
2k,
your case was when this is an integer and when this is not an integer, or you're going for.
so three cases:
Uh-huh.
even integer, odd integer, not an integer.
Okay, this whole thing, right? Okay, right. So your case is if this thing is integer, okay, or is
Yes, sir.
is is even integer, right? And the
Yes, sir.
second case is this is an odd integer.
Third case, not an integer.
Third case is not an integer. Okay.
So when first case, when it's an even integer,
Mm-hmm.
then n to the power m, which is m times log base 10 of n, where m is any natural number.
Mm-hmm.
So everything inside the float function are natural numbers or integers. So we can remove the float function and we will get that this number of digits is always odd because it's of the
Right.
form 2.
Correct.
So that is done.
That case is done.
And
Correct.
when it is an odd integer, so
Mm-hmm.
like 10 power 3, for
Mm-hmm.
odd powers, what we get is odd times odd, which is odd, plus 1, which is even. So it does not work.
Right. That's clear. Right.
And if it's not an integer, then what I reasoned was the fractional part is non-zero. Fractional part of log base 10 of n is
Yes,
non-zero.
and at some point it will not be odd integer. It will take all
Yes,
values. Yes.
it will take all values. Yes.
Right. So you are saying that this is like this is, uh, yeah, there will be a fractional part. No,
Yes, sir.
but wait. So let me also try if I can do it. This, it is like this, and yeah, and then well, let's say that this is even or something. Then
Yes, sir.
if we multiply, there will be some k. No.
So
So
what
yeah.
happens is, if we assume this log base 10 n thing is even, which is what we
Hmm.
want. So by contradiction, let us assume that as we keep
Hmm.
adding, this fractional part accumulates and it will
Hmm.
give a carry of 1. So at
Yes,
that point, it will become even plus 1
correct. Yeah,
odd.
you want this to be yeah, then it makes it easier because it will always remain even no matter what you multiply with. Correct. And
Yes,
then it will become odd because that will give a
carry.
right. Right. And at that point this will change. Yes.
Yes. So I think this solves it, sir.
Yeah, so that's the only case in which it works, right? In these cases, it's sort of, as you said, it's sort of a continuous, like it takes all the values, right?
Yes. Yes, sir.
And that is because of the carryover, right? So it's this thing, and right, absolutely, yeah, yeah, correct,
Yes.
correct. So this is okay. I mean,
And
yeah, it's not very difficult, but also, I mean, if that formula of log is not there with you,
yeah,
then it
like
becomes
that
a
didn't
little
occur to me.
ah.
Yeah.
But the number of digits and logs go hand in hand, right? It always is like that.
Yes.
So I
Yes.
remember once we
Yes,
were
sir.
discussing this lifting the exponent lemma, right? And there we used this log thing, but I don't know if we used it for. Anyways, now you know it for
Oh,
digits.
and sir, I like my friend is a part of some Discord server, and actually I
Uh,
think they use lifting the exponent lemma for CMI B1.
okay, they used it. Okay, all
Yes,
right.
sir. But actually CMI B1 is uh it's not that tough. So should we solve it now, sir? Or
Let's try it if we can solve it.
yes, sir. So CMI 2023 B1. This
Okay,
is
wait. Let me just change it.